In this section, we'll learn about another mathematical operation called interpolation. Interpolation is a mathematical technique used to estimate values within a range of known values. It helps create a smooth curve or function that passes through the given data points. Here is what interpolation does. In data analysis, when dealing with data sets containing missing values, interpolation is used to estimate those missing values based on the known data points. In function approximation, interpolation techniques like polynomial interpolation, spline interpolation, or rational function approximation are used to approximate complex functions with a simpler and computationally tractable form. Curve fitting. Interpolation methods like polynomial interpolation or spline interpolation are used to fit curves to experimental data. This is particularly useful in physics, chemistry, biology, and engineering, where experimental data must be fit to mathematical models. In signal processing, interpolation is used to increase the sampling rate of signal without introducing noise, thereby improving the signal's resolution. In numerical methods, interpolation is used to solve differential equations using methods like finite element method or the finite difference method. It is also used in root finding applications, wherein in numerical analysis, polynomial interpolation is used to find roots of functions by finding points where the interpolated polynomial crosses the x-axis. In finance, interpolation is used to construct the yield curve, which is crucial for pricing financial instruments, managing risk, and making investment decisions. In GIS systems, interpolation is used to estimate unknown values of spatial data based on values of surrounding known points. This is used in applications such as environmental modeling, agriculture, and urban planning. Computer graphics. Interpolation techniques are used to create smooth curves and surfaces in computer graphics, animation, and virtual reality applications. In machine learning, interpolation can be used to create additional features by interpolating existing data points. This can be useful when you want to generate more training examples. So these are some of the real-life applications of interpolation. In this section, we will study linear interpolation. In this section, we'll learn about linear interpolation. So the idea is that we have been given two known points and we have to find the value of missing data in between them. So here we have two known points, x1, y1 and x3, y3. And we are required to find the value of an intermediate point lying on x, having some x value, and we have to find the corresponding y value for that. So let's say that point is x2, y2, where x2 is known to us and y2 is required to be found out. Now here we can capitalize on the property that the slope of the line remains the same for all the 3 points. So starting with the known data points x3, y3 and x1, y1, we can calculate the slope by calculating the rise, which is y3 minus y1 over run. Run is x-axis, so we have x3 minus x1. So this gives us the slope, which is this part, this angle. Now this slope is exactly the same, the angle remains the same for the point x2, y2. So let's calculate the slope between x1, y1 and x2, y2. So again, we calculate rise over run. So we have y2 here and y1 here, which is rise. And we have run here, which is x2 minus x1. And we know that this angle and this angle are just the same. So both the slopes are going to be equal. So we equate equation 1 and 2, and then we solve it. And we can get the value of y2, the missing point, by this expression here. So this is very simple. Actually, if you see, this is just the equation of a line where the first term, this term, is slope multiplied by x plus the intercept. So linear interpolation, as the name suggests, assumes that there's a linear line passing through two data points, and hence the intermediate data can be calculated using the principle of having equal slopes. Let's shift over to Python to understand this more clearly.